In class, we did not have time to finish going over number 16, so I'd like to go over number 16 right now. The instruction said to find the x and y intercepts and the slope. Well, it's written in standard form, which means that you can't see the slope very well. So the first thing we're going to do is solve for y to get it into slope-intercept form. So I'm going to start by subtracting 4x from both sides because slope-intercept form has the y by itself on one side of the equals. So I have equals negative 4x plus 3. Then I'm going to divide both sides by negative 2. That way the y is by itself. So divide negative 2 into both of these. Negative 2 divided into negative 4 is positive 2x. Negative 2 into 3, that doesn't go evenly, so you just leave it. Okay, now at this point, this is in slope-intercept form, and as you know, the slope is the number that's in front of x if it's in slope-intercept form. So far we have that the slope is equal to 2. The other instructions for this problem were to find the x and y intercepts, and the way I like to do that, at least to organize it, is write this 0, 0 table. This reminds me that to find the y-intercept, I need to plug in 0 for x, and to find the x-intercept, I need to plug in 0 for y. So let's start with the y-intercept by plugging 0 in for x. So 4 times 0 minus 2y equals 3. That would be 0 minus 2y equals 3, which is negative 2y equals 3, and then you would divide both sides by negative 2. So y would equal negative 3 over 2. Now you could also see that right here, if you looked at the equation written in slope-intercept form, that is the y-intercept. Now it doesn't show you the x-intercept, that's just the y-intercept. So the x-intercept we will have to find separately. So the y-intercept is at the point 0, negative 3 halves, or negative 1.5. Okay, let's put that over here so that we have it all organized. Okay, for the x-intercept, I need to plug in y equals 0. So we'll write the same equation, except this time we're going to plug in 0 for y and simplify. So 2 times 0 is 0. So really that's just 4x equals 3. Divide both sides by 4 and you get 3/4. So that means that right here this the x value is 3/4 when y equals 0. So the x-intercept, did I say that right? The x value is 3/4? Okay. 3/4, 0. And so this is what the problem in the book was asking for. It wanted 3 things. It wanted the slope, it wanted the x-intercept, and the y-intercept. All right, let's go on to the next problem. For number 19, because as you can see it skipped up to number 19, we need to do 3 things. The first thing is they give us a line and they give us a point, and they want us to write the equation of a line parallel through this point. The next problem will be perpendicular, and then the last problem will be to graph all 3. So let's start out with the parallel line. Now, in order to write the equation of a line, you need to have a point and a slope, but it doesn't directly give us the slope right here. So we need to rewrite this in slope-intercept form. So I'm going to start by subtracting x from both sides, so that, because we're going to solve for y here, so 2y is equal to negative 1x plus 6. Divide both sides by 2, and that puts the equation into slope-intercept form. Alright, we're going to divide 2 into both of these terms. You can see 2 goes into 6 evenly. Remember that's a 1x, so 2 goes into negative 1. We just write negative 1/2 x plus 3. So this is the equation of the original line. This is the original line. Okay, now what is the slope of the original line? The slope of the original line is negative 1/2. Now if you want something to be parallel, you're going to have the same slope. So that means that the line that we're going to create is going to have the same slope. So we need to have it be m equals negative 1/2. We need to have the same slope. Okay, so now we've got a point and a slope. We're going to plug it into point-slope form. Y minus y1 equals m times x minus x1. And you've seen this before. This is point-slope form. It's used for writing equations when you have a point and a slope. And we have, let me just write this down here. Let's see, x minus. Okay, we have a point right here. We have the point 8, 3. So the 8 is the x and the 3 is the y. And then we just found the slope, -1/2. Now at this point, we're going to distribute and simplify to solve for y to get that into slope-intercept form as well. Okay, so -1/2 x. -1/2 times -8 would be +4, because half of 8 is 4, and negative times negative is positive. Last step is add 3 to both sides. So, sorry, it's hard to write here. Okay, so y equals -1/2 x plus 7. So this is what they are looking for. This is the parallel line. That's for part A. So we have the original equation written in point slope or slope intercept form. We have the parallel line written in slope intercept form, and next we're going to do the perpendicular line. Now we already changed this into slope intercept form on the other problem. Let's see, what was it? It was y equals -1/2 x plus 3. Okay, -1/2 x plus 3. So we know that the slope is -1/2. When you have a perpendicular line, that means it needs to be an opposite reciprocal slope. Reciprocal slope. So instead of negative, it's going to be positive, and instead of 1/2, it's going to be 2. So it's just 2, as in 2 over 1. Now this will be easy to write the equation. So we're going to use the point slope form again. Just write that down so that we know what we're doing. Okay, and we're going to substitute in the values of x and y and the slope. So again, we're using this point. 8 is the x, 3 is the y. You know, it's really common to get those mixed up when you plug them into the formula, so really be careful with that. Okay, and from here we're going to distribute and then just simplify. So let's see, y minus 3 equals 2x minus 16. We're going to add 3 to both sides, and that will allow us to solve for y. So y is equal to 2x minus 13. And this right here is the perpendicular line. So now we have the original line, we have the parallel line, and we have the perpendicular line. Now let's double check. For the parallel line, are the two slopes equal? Yes, because they have to be parallel. For the perpendicular line, is its slope the opposite reciprocal of the parallel line, and it's also the opposite reciprocal of the original line? So we're going to take those three equations, and I've written them down here, and we're going to graph them now. So this is our opportunity to practice graphing as well. All right, the original line, I wrote it in both the standard form and the slope-intercept form. I'm going to graph it using slope-intercept. So I'm going to mark, now remember this is the beginning point, and then you graph points using the slope. So we're going to begin at 3, and then we're going to use the slope, and we're going to go down 1 over 2, down 1 over 2, down 1 over 2. And anytime that you do a graph, you should just keep going to the end of your graph paper. Okay, so up 1, back 2, up 1, back 2. And then I'm going to make a line between these two, or between these points. So there's the first equation. Okay, for the line that's parallel, it has the same slope, but it begins at 7 instead. So it begins up here. Oops, I'm going to use a different color. Let's use this color. Okay, begins up here, but it still has a slope of -1/2. So it goes down 1 over 2, down 1 over 2, etc. Okay, and it also goes up 1, back 2. And when we make the equation, when we make the line to connect those, you will see that those two lines are parallel. They have to be, because they have the same slope. All right, the perpendicular line, however, if we want to graph it, it begins all the way down here at -13. That's why I had to kind of make this graph kind of big. The slope is 2, meaning 2 over 1, meaning rise 2, run 1, rise 2, run 1. And once you get all the way up to here where it's intersecting the graphs, you'll notice that it is in fact perpendicular. When I draw this graph right here, the line, those are perpendicular. You can see that that's how this works right here. Okay, let's see what we've got next. The next problem I'm going to save for the next video. Okay, so there we go. Stay tuned for the next video.